All right, for example 4, we're going to be working with three different equations that are all kind of similar, but with a couple of wrinkles that we want to watch out for. So um, for uh, for all three, we're going to be looking over this domain. The x's are going to go from 0 to 3 pi. And for the first one, should be pretty familiar at this point. Sine of x is equal to negative a half. So we ought to be able to, at this point, just based on the unit circle, remember I posted the link to the values from the unit circle that you know. So this first equation, the sine of x is equal to negative a half. Really what that's saying is that the y coordinates on the unit circle are negative 1/2. So that corresponds to these two angles, 7 pi over 6 and 11 pi over 6. So for that first equation, those are going to be the only solutions that we have. But we're going to be basing our solutions for these other equations off of this as our kind of our starting point. So these are our two solutions, 7 pi over 6 and 11 pi over 6. And for the first equation, that's all we have. If we extend the domain, if we apply any of our identities, we don't have any more solutions inside of our domain from 0 to 3 pi. So those are our two answers for part A. Again, I would expect you, based on what you know from the unit circle, you ought to be able to solve an equation like that and identify those two solutions in maybe 10 to 20 seconds, maybe 30 seconds tops. That should be the goal for how familiar you are with the unit circle. So if it takes you longer than that, you need to keep practicing until you get to that point. Okay, so for the other equation, for the next one, we have, in this case, the angle is 2x. It's a double angle here. So we want to think about what's happening with the domain here. If the x's are going from 0 to 3 pi, then that means the two x's could be as large as 6 pi, right? From 0 to 6 pi. Because if I just think at the top end of this domain, if x is positive 3 pi, then in this case, the 2x angle would look like a 6 pi. So whatever you see is being modified on the input, we can modify the domain the same way. So since the x's are double, we can just multiply the two endpoints of your domain by 2 as well. And that's the new domain that we're going to look in. So my two x's then reveal four other solutions here. The two x's, if I just start adding 2 pi to my initial starting point, 7x over 6 plus 2 pi would give me 19 pi over 6. Do it again would give you 31 pi over 6. And then the 11 pi over 6, if you add 2 pi to that, would give you 23 pi over 6 and 35 pi over 6. So we have these six solutions here just by adding 2 pi over and over again. And then that again until I get to the 6 pi limit. Then I have to do one last step to finish isolating for the x at the end, and that's just divide everything by 2. So if I divide everything by 2 to isolate the x here, then I get all of these six solutions right there. So that is the approach that we're going to take for these modified domains. The similar kind of approach is basically the same idea for the third one here. In this case, the angle is x minus pi over 6. So again, we're just going to modify the domain by subtracting pi over 6 from all three parts of my domain here until the input matches, right? So that's going to be negative pi over 6 on the lower end and 17 pi over 6 on the high end of my domain. And then if I find my solutions, this is going to give me three solutions here. I still have 7 pi over 6 and 11 pi over 6. I now have to include negative pi over 6. If I subtract 2 pi from 11 pi over 6, that gives me negative pi over 6, which is in this new modified domain. So I have those three. And then again, same idea. I have to finish by isolating the x here. So I have to add pi over 6 to both sides of the equation. And that gives me these three solutions here, 0, 4 pi over 3, and 2 pi.